of what reflections are. So I'm going to show this video. It's not too long, 3 minutes.
Welcome to Masonette Math. This is Tiana Masonette, and what we're going to do in this tutorial is practice reflecting across the x and the y axis on the coordinate plane. When reflecting anything across the x or y axis, there is a simple rule that we can follow. Whenever reflecting across the x-axis, the x values of the original coordinates stay the same, and the y values become opposite. And when reflecting across the y-axis, the original y values of your coordinates stay the same, and your x values become opposite. All right, let's go ahead and demonstrate the rules of reflection with two examples. One reflection across the x-axis and one across the y-axis. First, we're going to reflect the triangle ABC across the x-axis. I like to start by recording where our original points are located. Point A is located at -8, +2. Point B is located at -3, +2. And point C is located at -3, +8. Because we are reflecting our triangle across the x-axis, we know that our x values are going to stay the same, and our y values will become opposite. So we're going to write every x value the same and every y value opposite of its original. Now that we have our new coordinates, let's go ahead and plot them. Point A is located at -8, -2. Point B is located at -3, -2. And point C is located at -3, -8. Now that we have plotted our points, we can now see where our object will be reflected to. Notice how our x values stayed exactly the same and our y values are opposite values. All right, let's go ahead and reflect triangle ABC across the y-axis. A reflection across the y-axis requires making all y values the same and the x values opposite. So we're going to keep our y values the same and turn all of the x values, which are negative values, into positive values. Now that we have our new points, let's go ahead and plot our points. Point A is going to be reflected to +8, +2. Point B is going to be reflected to +3, +2. And point C will be reflected to +3, +8. All right, now we have the location of our new points. We can reflect our triangle across the y-axis. We can see that the y values of the reflected objects are exactly the same, but the x values are opposite.
Okay, so that is the gist of reflections. We did also look at the rules for reflections for when we have y equals x. When we have a reflection over y equals x, we switch the x and y values. And we also looked at a reflection for y equals -x. And when we have a reflection of y equals -x, we switch the x and y values and then change the sign. So that's basically the gist of reflections. Is there any questions about reflections after that? Questions, concerns? All right, so now we're going to get into translation. So let me share my other screen and we can begin. Okay, so translations. So a translation is a type of rigid transformation, but it is a rigid transformation which is often referred to as a slide in a plane. So basically, it is a direct slide. And I can actually show you this. Sorry, I did not mean to do that. So a slide in a plane. Nope. So here you see that translation being, or this triangle being slid over in the plane. So a translation often referred to as a slide in a plane. Okay. 1 second. All right. So a translation is a type of rigid transformation, which basically means the shape doesn't change, the lengths of the sides don't change, the angle measures don't change. Nothing dealing with the size of the figure changes, only the location, right? It gets slid from one side to the other side. So it's a rigid transformation that moves every point of the pre-image of an object the same distance and direction to create an image. So therefore, the translation preserves the angle measures, the length, the shape, the size, and the orientation. So in this instance, the orientation is preserved because we're not doing any flipping of it or any turning of it. It's just slid from one spot to the other. So what I mean by orientation is preserved. Here we see this A is facing upward and it will stay upward on this side. Same thing if we look at left and right. D is on the left side, D will stay on the left side. If B is on the right side, B will stay on the right side. So orientation in this instance is preserved, where in reflections, it wasn't preserved. Okay, so very much like reflections, we also have translation rules, but they're a little bit different. So on a coordinate plane, you can represent a translation by a function that takes the input x, y, so our original coordinates, and maps it to an output, our resulting coordinates. And what happens to the x and y is we add certain units to x or subtract certain units from x, and we add or subtract certain units from y's. And so A will represent the number of units translated horizontally, which can mean left to right, and B will represent the number of units translated vertically, so up and down. So if we add something to x, say we add a value for A, what we're doing is we are either moving the image left or right. If we add something to Y, more specifically a unit B, we are moving up and down. So the way that we represent this is we use a function rule, which looks like this. We have T, which stands for translation, and then A and B. A will tell us what happens to our X, and B will tell us what happens to our Y. So for example, here I have T, which represents my translation, and I have a positive 4. If I have a positive 4, I am moving to the right. So I will move 4 units to the right. I also have a positive 5. Remember that B tells me what happens to my Y, so that means I'm moving 5 units up. So whenever I have a positive A being used, I am moving to the right. Whenever I have a negative A being used, I move to the left. Whenever I have a positive B, I am moving up. And whenever I have a negative B, I am moving down. Okay. So for example, I have this other one. As you can see, I have a translation. But this time I have a negative 4. So that means I'm moving to the left 4 units, right? Left because it's a negative. I also have a negative 5. Well, because I have a negative, I am moving down. Okay, any questions about this right here? Questions, concerns? Okay. So let me just go over some more examples just to make this make more sense. Okay, so say I have something that says T, which represents my translation. Remember that T starts with T. A will be on this side. B will be on this side. Okay, so let's say I have T, negative 5, and 6. Well, this tells me that I have a negative A, right? Because that's where my A is located. And so because of that, when I have a negative A, I move 5 units to the left. Why is it to the left? Because I have a negative, means left. Here I have a positive B, that's a positive number. A positive B tells me I move up, so I move 6 units up. So my translation is 5 units to the left, 6 units up. Okay. One more example, say I have T, 1, and 3. Well, here I have a positive A, so I move 1 unit to the right. Since it's a positive A, and a positive B. Positive B means I move up, so I move 3 units up. So 1 unit to the right, 3 units up. That'll be that translation. Okay. Is there any questions about this? Questions, concerns? Okay. Okay. What we're also going to see is that we can create a mapping rule, which looks like this. And this mapping rule is very straightforward. It tells me I take my original coordinates, and it directly tells me what is added to my x and what is subtracted from my y, or what is subtracted from my y, or in this instance, it's added from my x and subtracted from my y, but it can tell me what's added to my y and subtracted from my x. But basically, this rule is just telling me what to actually directly do to that x and y. So, for example, give me 1 second. Okay. So this is telling me that I'm going to add 6 units to my x and subtract 4 units from my y. So I just directly do that. So it's telling me to look at vertex D. Vertex D is originally located at -2.5 and 5. Okay, that's my original location. So that is my original x, y. So what this is telling me to do is to directly add 6 units to my x and subtract 4 units to my y. So that means -2.5 plus 6 is 3.5. 5 minus 4 is 1. So I directly do what it's telling me to do to my x to my y to my original x and y, therefore giving me my resulting coordinate. Okay? And basically, I would do that for each of the different vertices here, and I would see where that thing gets translated. All right? Any questions here? So basically, let me erase this. I have my mapping rule, which tells me whatever is added to subtracted to x, whatever is added to subtracted to y. So say I start with the original coordinates, 1 and 3. Okay? And then I get the following rule. X plus 3, y minus 2. Okay? Well, what is this rule telling me? It's telling me to directly add 3 to my original x and directly subtract -2 from my original y. So I start with 1. 1 plus 3. 3 minus 2. What does that give me? 2 and 1. So that is my resulting coordinate after that translation. So my mapping rule is telling me what to do to my x and y. Okay? This can also be represented in the other form that we saw, which was the function rule. And the way that that would be done is translation, +3, right? Because that's a +3, -2, -2. So that tells me the same thing as my mapping rule. It's basically the same thing. Right? They're both telling me to add 3 to x and subtract 2 from y. Okay? Any questions? So this is my function rule. Or this is the way to represent my function rule. And this is the way we represent our mapping rule. Okay? All right. Okay. So there may be some instances in where we're actually asked to identify the rule given our pre-image and our image. So here we're not given the rule, but we're being asked to identify it. So we want to identify how our pre-image is that without the prime notation, is translated to create our resulting image. Well, the way we identify that is we want to identify a specific coordinate on the pre-image. So I'm going to go with Q. Q here is located at -1 and 4. And then after the translation, it's resulting here. So it becomes 1 and 5. So I want to see how these interact with each other. right? What is being added or subtracted to my x's and y's to create this? So I have -1 equals 1, and 4 equals 5. So what's happening here? Well, it looks like here I'm adding a +1. So to my y, I add 1. And here, I'm adding 2, right? Because -1 plus 2 gives me 1. So what do I need to do? Add 2 to my x and add 1 to my y. So I can create the following mapping rule. X plus 2, y plus 1. Or if I wanted to write the function rule, 2 and 1, right? Same thing, it tells me to add 2 to x, add 1 to y. All right? Any questions about this? And you can also see this directly. Our y tells us what we do, how we move up and down. We move 1 unit up. Our x tells us how we move left and right. We move 2 units to the right. Up is a positive, and to the right is a positive. So that's another way to go about doing it. Okay? Any questions? Questions, concerns? And we'll look at some more examples later on. Okay? All right. And then lastly, we might have a question that looks like the one we saw with our other reflection. And this one tells us to find the pre-image. So we want to work backwards, right? So this is our image. We want to find where our pre-image was originally located. Well, let's go ahead and identify the points of these vertices. So J prime is located at -4 and -1. K prime is located at -3 and 1. And L prime is located at -2 and -4. So what I want to do was identify what my coordinates were before this specific translation was applied. So if this specific translation was applied, I want to do the opposite of it. So instead of subtracting, I'm going to add. So I'm going to add 7.5 and add 4.1. So I'm going to add 7.5 to my x and add 4.1 to my y to find out where my original coordinates were. And when I do that, I will find out that J was originally located at 3.5 and 3.1. K was originally located at 4.5 and 5.1. And L was originally located at 5.5 and 0.1. So I'm just adding directly to my x and my y's, right? I'm just adding them directly. And the reason I'm adding is because I'm working backwards. Okay? And so I can go ahead. Give me 1 second. There is my J. My K. And my L. And my L. Right? And I can see where that original pre-image was located. Okay, any questions about this? So finding the pre-image of the translation is a lot easier because all you're doing is doing the opposite. So here we subtracted, so now we're going to add. Okay. All right, so what did we learn today? Well, we learned that a translation on a coordinate plane can be represented using the function rule, where A tells us what we do to our x and B tells us what we do to our y, or the mapping rule, where we're told directly what we add or subtract to x or what we add or subtract to y. A indicates how we move horizontally, so left and right. If we have a positive A, we move to the right. Negative A, we move to the left. B tells us how we move vertically, and so if we have a positive B, we move up. If we have a negative B, we move down. Okay? Any questions about this? Questions, concerns? Okay. Then here's the different terms we looked at today. Any questions? All right. If there's no other questions, you guys may log off, and I'll see you tomorrow for some practice problems. Bye, guys.